Hi class, today our topic of discussion is isosceles triangle. Now we know we have done this in earlier classes that in isosceles triangle two sides are equal, then only the triangle is known as isosceles triangle. Let us take an example. Suppose we take a triangle ABC and I say that AB is equal to AC. Then triangle ABC is your isosceles triangle. Now the angles opposite to the equal side are known as base angle, which means angle B and angle C are known as base angle, and angle A in this case is known as vertical angle. Now, in an isosceles triangle, we need to remember two theorems. Theorem 1, which says that the angles opposite to the equal side of an isosceles triangle are equal. How come? Just let's see this one. Suppose we take an isosceles triangle ABC, same case. I take AB is equal to AC. Now what I'll do, I'll draw AD. What I'll draw? Draw AD, which is bisector of angle A meeting BC at D, which means this angle and this angle are equal. Now we have done congruency. Look at triangle ABD and triangle ADC. AD is equal to AD, that's common. AB is equal to AC, that's already given to us. And by construction, angle BAD is equal to angle CAD, because AD is the bisector. Okay, which means triangle BAD is congruent to triangle CAD, side angle side. And if these two triangles are congruent to each other, then the corresponding parts are also equal, which means, see, angle B corresponds to angle C, which means I can say, which implies angle B is equal to angle C, CP, CT, isn't it? Which means the angles opposite to the equal side in an isosceles triangle are equal. This was theorem 1. Theorem 2 is nothing but the converse of this one. Converse, okay, which means the sides opposite to the equal angles in an isosceles triangle are equal, which means the reverse of this, the converse of this, which means if you have a triangle ABC and I tell you that this angle and this angle are equal, it means that this side and this side are equal. So while doing sums, we need to know these two theorems. Now look at exercise 10.3 from M L Aggarwal. Now look at sum number 1, which says that ABC is a right angle triangle. Let us draw the right angle triangle ABC, where angle A is 90 degree and AB is equal to AC, which means this side and this side are equal. Now it's an isosceles triangle. Angle opposite to the equal side are equal, which means I can say that angle B and angle C are equal. Suppose it is X. Right, angle B is equal to angle C is equal to X. Let And why they are equal? Because AB is equal to AC, isn't it? Now, in a triangle, angle sum property we know. If you add all the angle, you should get 180 angle sum property, which means twice of x equals to 90, which means x equals to 45 degree, which implies angle B is equal to angle C is equal to 45 degree each. Done. Now look at this sum. Sum number 3 says that show that every equiangular triangle is equilateral. What do you mean by equiangular? Equiangular means all the angles are equal. So let us take a triangle ABC, and given angle A is equal to angle B is equal to angle C. The first thing, look, angle B is equal to angle C. So if two angles are equal in a triangle, the opposite side are also equal, okay, which means I think AC is opposite to angle B and AB is opposite to angle C, which means AC equals to AB, isn't it? Now similarly, look carefully, angle A is equal to angle B. Again, the side opposite to the equal angles in a triangle are equal, which means to angle A, I think BC is opposite. To angle B, we have AC, isn't it? So if you compare 1 and 2 on comparing 1 and 2, what do we get? See, AB is equal to BC is equal to AC, which means triangle ABC is an equilateral triangle. Done. They've told us to prove that only. Clear? Now let us look at the next sum. Now look at 4 part 2. They have given a figure and they have told us to find x. First thing, look at triangle in triangle PRS. They have given PR is equal to RS, which means angle PSR will be equal to angle RPS. RPS, why? Because opposite angles to the equal side in an isosceles triangle are equal. Okay? Opposite angles to the equal sides, they are equal, see? So we can say that this angle, which is angle RPS, is equal to 30 degree, which is equal to this angle. Clear? Now look carefully. We know in triangle C PQR, in triangle PQR, look at this angle. This angle is the exterior angle for this triangle, which means this angle will be equal to sum of opposite interior angle, which means can I write angle PRQ is equal to angle RPS plus angle PSR. Exterior angle equals to sum of opposite interior angle. Okay? Now, which means angle PRQ is equal to 30 plus 30, that's 60 degree. Okay? So we got this as 60 degree. Now look at triangle PQR. In triangle PQR, x plus 52 plus 60 will be equal to 180. Why? Angle sum property, which means x will be equal to 180 minus 112. So x will be equal to 68 degree. Done. And that's my answer. Now look at sum number 4 part 3. Over here also they have given a known quantity x. Okay, now look at triangle. Same. First look at triangle DBC. In triangle DBC, angle DBC is equal to angle DCB is equal to 27 degree. Why? Because DB is equal to DC. See, opposite to DB you have angle DCB, and opposite to DC you have angle DBC. So they will be equal. So if this is 27, this has to be 27. Done. Now look, again same. This angle will be equal to this angle plus this angle. Exterior angle equals to sum of opposite interior angle. We have done that. You know, if this is your triangle, then this angle is equal to this angle plus this angle. Exterior angle equals to sum of opposite interior angle, which means can I write angle ADC? Angle ADC is equal to angle DBC plus DCB. Why? Because exterior angle equals to sum of opposite interior angle. Am I clear? Which means angle ADC is how much? 27 plus 27, that's 54 degree. Done. Now look at the last part. You know, this is your x. Okay, this we just got as 54. Now look at triangle ADC. In triangle ADC, angle A and angle D will be equal because they are opposite to the equal side, which means can I write angle CAD? Angle CAD is equal to angle CDA is equal to angle or ADC, whatever, that is equal to 54 degree each. Why? Because AC is equal to DC. So we got this as 54 degree. Now look carefully. X plus 54 plus 54 will be equal to 180. That's angle sum property, which means x will be 180 minus 108, which means x will be 72 degree. Done. Clear? Now let us look at the next sum. Now look at sum number 6, part A. In the given figure, AB is equal to AD and BC is equal to DC. Find angle ABC. They are asking this angle. What I'll do? I'll first do a construction. And what is my construction? Join DB. So when you join DB, look carefully. You're getting two triangles. First of all, look at triangle BCD. In triangle BDC, this angle and this angle will be equal. Why? Because BC is equal to CD. Angle opposite to equal sides are equal in magnitude, which means angle CBD is equal to angle CDB. Suppose it is X. Let. And why they are equal? Because BC is equal to CD. Now, if this is X, this is X, then we can say that X plus 116 equals to 180. Angle sum property, which means 2x equals 2. This is 64, which means x is 32. Done. Now look at triangle. In triangle similarly, ABD. In triangle ABD, if you look carefully, this angle and this angle will be equal. Why? Because AB is equal to AD. So angle ABD is equal to angle ADB is equal to ADB. Suppose this is Y. Let. And why they are equal? Because AB is equal to AC. Now I have taken this as Y and this is Y. Now look carefully. In triangle ABD, I can say Y plus 54 equals to 180. Same angle sum property, which means can I say 2y equals to 180 minus 54, that's 126. So I can say y equals to 63. Once you get y, look carefully, they have asked for angle ABC. Angle ABC is nothing but x plus y, which is equal to 32 plus 63, that's 95 degree. Done. Now look at sum number 6, part C. Now over here what they have told. Look carefully. In the given figure, AB is parallel to CD and CA is equal to CE if angle ACE is 74 and BAE is 15. Find X and Y. Very easy. First of all, look in the triangle ACE. In triangle ACE, if you look carefully, AC is equal to CE, which means this angle and this angle will be equal. They are opposite to equal sides. Suppose this is Z and this is also Z. So I can say angle CEA is equal to angle CAE equals to Z. Let why they are equal? Because AC equals to C. Now I can say, if you look carefully, in that same triangle, Z plus 74 equals to 180. Angle sum property. Done. Which means 2Z equals to 180 minus 74, which means 2Z equals to 106, which means Z equals to 53 degree. So this you got 53 and this you got 53. Now look carefully. In triangle AEB, X will be equal to Z plus 74. Exterior angle equals to sum of opposite interior angle. Remember, if you have any triangle, suppose like this, then this angle, exterior angle, is equal to this plus this. Remember? So we can say X is equal to angle ECA plus EAC. Why? Exterior angle equals to sum of opposite interior angle. Done. Which means X will be equal to 74 degree plus Z is how much? Z is 53. Clear? So X is what? X is 127 degree. Done. Now look carefully. This angle, this entire angle, and this entire angle, they will add to give 180, isn't it? Because they are co-interior. Okay, so I can say, look carefully, the last portion, Z plus 15 plus 74 plus Y equals to 180. That's co-interior. We know if these two are parallel line, then this angle and this angle add to give 180. They are co-interior angle. Now we put the value. Z is 53, we know, plus 15 plus 74 plus Y equals to 180, isn't it? So this will be how much? Look carefully. Y plus, this is 70, 133, 138, 142 equals to 180. Therefore Y equals to 38 degree. Done. Is it clear? Somebody can find this angle and equate it with Y, alternate angle. That's also same thing, okay? Now look at the next sum. Now look at sum number 7. In triangle ABC, AB equals to AC. I draw the figure. In triangle ABC, AB is equal to AC. And angle A is equal to 5x plus 20 degree. And each of the base angle, which means these two are equal angles again, is 2/5 of A. So we can say angle B is equal to angle C is equal to 2/5 of 5x plus 20, which is equal to 2. 5 it cancels, so it becomes x plus 4 which is 2x plus 8. Now in triangle ABC, can I write 5x plus 20? This angle we know it is 2x plus 8. This angle again same, 2x plus 8. This will be equal to 180. Angle sum property, isn't it? Now this is 5. This is 9x plus 36 equals to 180. That's 9x equals to 144. That's x equals to 144 by 9. That's 16. So once you get x, they have asked for angle A. So angle A is nothing but 5 times x, which is 16, plus 20. That's 80 plus 20. That's 100 degree. Done. Now let us look at sum number 8b. 8 part B says, in the figure prove that angle BAD is to ADB is 3:1. Very interesting. First of all, look at triangle ABC. Can I say this angle and this angle are equal because they are opposite to equal sides? So angle BAC is equal to angle BCA. Why? Because BA equals to BC. Take this as equation 1. Okay. Now look at triangle ACD. Angle CAD similarly is equal to angle CDA. Why? Because CA is equal to CD. This is angle equation 2. Now add these two. Adding 1 and 2. What do you get? Angle BAC plus angle CAD is equal to angle BCA plus angle CDA. Done. Now look carefully. Angle BAC which means this angle, and CAD which means this angle together forms BAD. So angle BAD is equal to angle BCA plus CDA. This is equation 3. Now look carefully. Again, in triangle ACD, can I write this angle is equal to this plus this exterior angle equals to sum of opposite interior angle? So I can write angle ACB is equal to angle CAD plus angle CDA. Done. This is exterior angle equals to sum of opposite interior angle. Now look carefully. These two angles are equal. So can I write angle ACB is equal to twice of CDA? Because both the angles, this and this, are equal. Now look carefully. Angle BAD. Instead of BCA, ACB, same thing. Can I put twice of CDA plus angle CDA? Isn't it? ACB and BCA, same angle. Be careful, okay? So this becomes angle BAD is thrice of angle CDA, isn't it? So this becomes angle BAD by angle CDA is 3:1. Am I clear? Now look carefully. ACDA or ADB means the same angle, which means can I write angle BAD CDA? CDA is this angle and ADB is the same angle. So angle ADB is 3 by 1 is equal to 3:1. Done. Very interesting. Now let us look at the next sum. Now look at sum number 9, where is in the adjoining figure D is the midpoint of BC, which means this and this will be equal. DE and DF are perpendiculars to AB and AC, which means this is 90 degree, such that DE is equal to DF. They have given DE is equal to DF. Prove that ABC is an isosceles triangle. So if you can prove that two angles of the triangle ABC are equal or two sides are equal, then it's an isosceles triangle. let us look at triangle BED, triangle BED, and triangle CFD. Look carefully. BD is equal to CD, that is given to us, isn't it? Similarly, DE is equal to DF, that is also given to us. Okay, angle DEB is equal to angle DFC, which is equal to 90 degree, which is also given to us, which means these two triangles are congruent because this becomes a hypotenuse of both the triangles. So I can say triangle BED is congruent to triangle CFD. Why? RHS, which means, can I say this angle and this angle will be equal, CPCT, which means angle B is equal to angle C, CPCT. Now if these two angles are equal, look at the bigger triangle. In triangle ABC, angle B is equal to angle C. Just now we have proved that. And if these two angles are equal, the opposite sides are equal, which means AC is equal to AB, implies triangle ABC is an isosceles triangle. Done. Now let us look at sum number 10. In the adjoining figure, AD, BE and CF are altitudes, which means this and this are 90 degree each. If AD is equal to BE equals to CF, means all the altitudes are equal. Prove that ABC is an equilateral triangle. Now first of all, look at triangle, I'm just splitting it, BCF and triangle BCE. Look carefully, this is 90, this is 90, okay, and BC is equal to BC, that's common, and they have given CF is equal to BE, in which means they are congruent. Look carefully, in triangle BFC and triangle CBE. Look carefully, angle BFC is equal to angle CEB equals to 90 degree, that's given to us. BC equals to BC, that's common, and that's a hypotenuse. And similarly CF is equal to BE, that's also given to us, which means triangle BFC is congruent to triangle CEB, and the reason is RHS. Now if they are congruent, then can we tell that angle B and angle C here in these two triangles will be equal, CPCT? Look, so I can say, which implies angle FBC is equal to angle ECB is equal to ECB, CPCT, which means in triangle ABC, if you see the larger picture, I can say angle ABC is equal to angle ACB, isn't it? Which means in triangle ABC, if I can draw ABC, if I say this and this angle are equal, I mean AB and AC are equal, which implies AB and AC are equal, opposite sides to equal angles, they are equal, isn't it? Now suppose this is your one. Now look at triangle CFA and triangle ADC. If I can draw, look carefully. This is your CFA and this is your triangle ADC. Okay, this is 90 degree, this is 90 degree. CF is equal to AD, that's given to us, isn't it? And AC is equal to AC, that's common side. So these two triangle will be congruent. RHS, I can say, look carefully, angle AFC is equal to angle AFC is equal to angle ADC is equal to 90 degree, that's given to us. CF is equal to AD, that is also given to us, and AC is equal to AC, that's common, which means triangle CFA is congruent to triangle ADC, yeah, triangle ADC, isn't it? This is RHS. And if these two triangles are congruent, can I tell this angle and this angle are equal? CPCT, look carefully. Angle CAF is equal to ACD. Why? CPCT. Now if these two angles are equal, look at the larger picture. In the bigger triangle, I got this angle is equal to this angle. This is your A, this is your B, and this is your C. So in triangle ABC, I can say angle BAC is equal to angle BCA, which implies BC is equal to AB, opposite sides of equal angle. Now look carefully, this is your 1 and this is your 2. If you equate these two, or if you look at these two, we clearly get AB equals to BC is equal to AC. And when all the three sides are equal, ABC is an when all the three sides are equal, we can say that triangle ABC is an equilateral triangle. Proved. Now let us look at the next sum. Now look at sum number 11. In a triangle ABC, draw a triangle ABC. In a triangle ABC, so name it ABC. AB equals to AC, it's already given to us. D and E are points on the side AB. Suppose we take over here as D, over here as E. On the sides AB and AC respectively, such that BD equals to C. So BD and EC, these are equal. Show that DBC, which means this triangle, and triangle ECB, which means this triangle, are congruent. We'll do the first part. First, let us see. Let us break this into two triangles. Let it rather. Look at DBC and look at BCE. BC is equal to BC, that's the common side. BD is equal to C, they have already given. And in triangle ABC, if you look carefully, this angle and this angle are equal, which means this angle are equal, which means these two are congruent. Now I'll write this, look carefully. In triangle DBC and triangle ECB, okay, BC equals to BC, that's common, okay, BD equals to CE, that's given to us, and angle DBC is equal to angle ECB, and why they are equal? Because AB is equal to AC. I'm talking about the bigger triangle ABC, and if these two sides are equal, these two angles are equal, which implies angle ABC is equal to ACB, okay, which implies triangle DBC is congruent to ECB, triangle ECB, and the result is what? Side angle side. Done the first part. Now if these two are congruent, then DCB, which means this angle, and EBC will be equal CPCT, which means, can I say angle DCB is equal to angle EBC, and that's CPCT. Done. Okay, first part done, second part done. Now look at third part. Prove that OB is equal to OC, where O is the point of intersection of BE and CB. So let us put O over here. Done. Now look at triangle BOD, which means this one. Look at triangle BOD and EOC and EOC. Now look carefully. In these two triangles, first of all though, this angle and this angle will be equal, vertically opposite angle, okay. In triangle BOD and triangle COE or EOC, alright, EOC, angle BOD is equal to angle COE, that's vertically opposite angle, okay. Now BD is equal to C, this and this are equal, they have already given. BD is equal to C, given. Now one more thing, if you look carefully, this angle and this angle are equal. Why they are equal? Because we have already proved that these two triangles are congruent, which means this angle and this angle, can I write over here, angle BDC is equal to CEB, CPCT, and BDC is nothing but this angle, and CEB is nothing but this angle, which means, can I write angle BDO is equal to CEO. Why? Because triangle, we can say BDC is congruent to triangle BDC is congruent to triangle CEB. We have already proved. Okay. So these two triangles are congruent. Triangle BOD is congruent to triangle BOD is congruent to COE. Why? Angle side. BOD and COE. Yeah, the vertices should match, which means OB will be equal to OC, CPCT. Done. Now let us look at the next sum. Now look at sum number 12. ABC is an isosceles triangle in which AB equals to AC. I'll draw the figure first. Let us take this figure ABC and AB equals to AC. P is any point in the interior of triangle ABC. P I have taken over here, such that ABP and ACP are equal, which means I'll join this, look carefully, and this angle are equal. They have given. Prove that BP equals to CP and AP bisects BAC. First of all, look at the first part. Look at, in triangle ABC, AB is equal to AC. These two sides are equal, which means the angles opposite to these two sides will be equal, which means can I write angle ABC is equal to ACB. Now ABC I can write as ABP plus PBC. PBC, look carefully. And angle ACB I can write angle ACP plus PCB. I can write this. Now ABP and ACP are equal, which means these two cancels out. So what remains? Angle PBC is equal to PCB. So in triangle PBC, we just got angle PBC is equal to PCB, which means PB will be equal to PC, which means PP equals to CP. Why? Opposite sides of equal angles are equal. We know. This was the first part. Okay, done. Now look at the second part. Look at triangle APB, triangle APB and triangle APC. AB is equal to AC given. Angle ABP equals to angle ACP, that is also given to us. BP equals to CP, just now proved, which means these two triangles are congruent side angle side. See, triangle APB is congruent to triangle APC. Why? Side angle side. And if these two triangles are congruent, then this angle and this angle will be equal, CPCT, which means angle BAP is equal to angle CAP CPCT. And if these two angles are equal, it clearly means AP bisects angle BAC. And that's proved. Done. Now let us look at the next sum. Now look at sum number 14a, which says that in the figure CDE is an equilateral triangle formed on the side CD of a square ABCD. Show that triangle ADE and BCE are congruent to each other, and hence AEB is an isosceles triangle. Now first of all, look at this angle. We'll calculate this angle. Okay, angle ADC is equal to angle BCD, and both are 90 degree. Okay, angles of the square, this angle and this angle, and angle EDC is equal to angle ECD. This is equal to 60 degree. That's an equilateral triangle. Is this square? It is a square, isn't it? Which means if you add them, then angle ADC and EDC forms angle ADE. Look carefully. And these two, when you add, it becomes angle ECB. This is equal to 150 degree each. Okay. Now look at triangle. In triangle ADE and triangle BCE. AD is equal to BC, side of a square. Isn't it? DE is equal to CE, side of an equilateral triangle. and we just now got angle ADE is equal to BCE, just now proved, which means this is equal to this, and this is equal, which means can I write triangle ADE is congruent to triangle BCE, side angle side. And now if these two triangles are congruent, can I write AE is equal to BE, CP, CT? Now first part is done. Now look at second part. In triangle AEB rather, they have written that only, AEB. Look carefully, we just now proved AE is equal to BE, proved, which means triangle AEB is an isosceles triangle. Done. Clear? Now look at the last sum. Now look at this sum, very interesting. In the figure ABC, AB is equal to AC. Bisector of angle A meets BC at D. Prove that BC equals to twice ED. Now look carefully. Triangle ABC is a right angle triangle. Right angle triangle. And AB is equal to AC, which means this angle and this angle will be equal. And this is of course 90 degree, isn't it? So we can say angle BCA will be equal to angle ABC will be equal to, suppose, X. Let. Why? Because they are opposite to equal side, okay? Which means if this is X, and this is 90. So I can write X plus 90 equals to 180. Angle sum property, which means twice X equals to 90, which means X equals to 45 degree, isn't it? Now, so this is my 45 degree and this is also 45. Now we know that AD is the bisector given. AD is the, see, bisector of A meets BC at D, which means AD is the bisector of angle A, which means angle BAD will be equal to CAD, will be equal to 90 by 2, that's 45 degree, which means this is 45 degree and this is also 45 degree each. Clear? Now look at triangle ADC and triangle ADB. AD is equal to AD, that's common. AC is equal to AB, that's given to us, isn't it? And this angle and this angle are equal, which means angle DAC is equal to angle DAB, 45 degree each. Just now we got 45 degree each, which means, can I say triangle CDA is congruent to triangle BDA, and the reason will be side angle side. The reason is side angle side. And if these two triangles are congruent, can I tell that this side and this BD and CD are equal CPCT, which implies CD equals to BD, CP, CT. Done. Now look at the last part. In triangle ABD, look carefully, angle DAB is equal to angle DBA equals to 45 degree, which means AD will be equal to BD. Why? Opposite sides of equal angles, they will be equal, which means this and this are equal. Now look carefully. BC is equal to CD plus DB. Done. So I can write BC equals to, instead of CD I can write BD. So BD plus BD, which is twice BD. Instead of BD I can write AD. So which means BC equals to twice of AD. That's proved. Clear? And this was the last sum for the chapter. Okay? Take care.